Hello everyone. My name is Kunal and I am your physics tutor. And we are actually doing a transverse wave. Hello everyone. My name is Kunal and I am your physics tutor. And we are actually doing a transverse wave. And today is our lecture number third. Let me quickly recap the things कि हमने previous classes में क्या क्या चीजें cover करी थी. So in previous classes we actually deal with something like हमने general equation हमने लिखे थे. Then we actually draw the curves, right? हमने कर्व्स को ड्रॉ करा था, whatever you can say ग्राफ को ड्रॉ करा था. एंड देन हमने बेसिकली जो प्रीवियस सेक्शन था उसमें हमने मेनली जो फेज पे बात करी थी, राइट? कि फेज क्या होता है. सो वी एक्चुअली डील विद आल्सो लाइक फेज. सो जिसमें हमने बात करा एग्जैक्टली द लीनियर कॉम्बिनेशन ऑफ एक्स वी एंड टी एंड और भी सारी चीजों पे बात करी थी, राइट? So in today's class we are gonna start our new topic which is actually termed as equation of traveling wave, right? So wave on string. So in today's class, we are gonna learn about the lots more thing about the traveling wave on the string. Okay, so let me quickly draw a figure here so that it will be clear and understandable to you. Let's take maybe some different colors. Okay, so let us suppose that this is actually our string and there is a mass held m. Let me insert a straight line here. That is fine. Now, what I'm trying to say is this is actually, I hope I can make this in one chance. Okay. Okay. So you can extend it as well. So this is actually our positive x-axis and this distance is actually y. Let me take some different color to note. Okay. So what I'm trying to say, there is a spring mass system, single spring block system, or you can say spring block system. Okay. And this is actually above and the mass is actually lying at time t is equal to 0 and x is equal to 0. It is at the height of y from the x-axis. And the wave is, and this is actually this mass is actually executing simple harmonic motion. So there is a wave creating in the surrounding and the velocity of wave is in the positive x direction. Okay. So at some, like if I'm gonna talking about like some x is equal to x and some t is equal to t. So I'm finding that there is some next uh displacement which is actually is equal to something like y dash, right? So we have a different value of particle, or we can say we have a different coordinate of the particle at different time, right? Or we can say at different value of x. So as we all know that the general equation of a wave is something look like x is a function of x and t, and it is actually equal to a sine omega t minus ax plus 5, in which we all know that we can also write it as like omega into t minus x by v, and we all know that like omega by v is actually our k, and so yeah, so right. So this is actually, this equation is, you can say, one of the equation of traveling wave, and the wave is actually traveling in the positive x direction with the velocity of something v, right? So the things that you have to keep in mind, that the general equation of wave is actually the function of x and time. Okay. And it is actually, and whenever you have to write the general equation of wave, okay, the general equation of wave. So what I am trying to do here is, for the traveling wave or the equation of traveling wave which is for a string, so what you have to do, let me tell you again. मैंने यहाँ पे क्या किया, मैंने यहाँ पे एक string लिया. This is actually our string. ओके, और मैंने स्ट्रिंग को इस मास m से कनेक्ट करके और इसको थोड़ा सा नीचे ला गया था, छोड़ दिया. नाउ इट स्टार्ट एग्जीक्यूटिंग सिंपल हार्मोनिक मोशन इन सच वे, राइट. हमने जैसे पहले भी डिस्कस करा था. दिस इज एक्चुअली आवर मेन क्वेश्चन एंड इट स्टार्ट डूइंग लाइक दिस. नाउ अब क्या होगा कि ये जो स्ट्रिंग है ना, ये कुछ इस तरीके की वेव फॉर्म बना रही होंगी. यू कैन ट्राई दिस एट होम, राइट. आपने एक स्प्रिंग लेनी है एंड ये मास नहीं भी आप ले सकते हो. बस आपने करना क्या है कि जो नीचे वाला जो एंड है उसमें एक आप स्ट्रिंग की एक छोर को बांध दो, राइट. आपने बस करना क्या है कि स्ट्रिंग के एक एंड को और स्ट्रिंग के एक एंड को वहां पे बांध के और इसको बस स्प्रिंग को थोड़ी सी नीचे डिस्प्लेस करके छोड़ देनी है. तो इट स्टार्ट लाइक ये जो string A, it start making wave. And since we already know like how to write the equation of wave when wave is actually traveling along the positive x direction. So we all know that like t minus x by v, and same I'm writing like y as a function of x and t, and it is actually equal to a sine omega t minus kx plus phi. So this is actually the one of the equation of the traveling wave. I hope this will be clear to all of you. Uh, Now here we have some abbreviation like what is y, what is a, and what is omega. So let me try to tell you. So y is actually displacement of particle, and a is actually amplitude of particle, and omega you all are familiar with, which is actually angular frequency. K you all guys familiar with, which is actually the angular wave number, right? And phi is like initial phase. So these are some common abbreviation we use in the above equation. I hope this will be clear to all of you, right? So y is actually displacement of the particle, है ना. ये जो मतलब basically because we have a lot of particle there. So what is the actually displacement of the particle from there? Here, right? And a is actually the amplitude of the particle. Okay. And the next thing is like you always familiar with. So let's start writing some like velocity, acceleration, and the other equation of the traveling wave. So equation of traveling waves as, look at here. So we have a equation which is actually the y, which is nothing but a function of x and t, which is actually as a sine omega t minus kx plus y, right? So this is actually our traveling wave equation. Now we are going to derive some other equations like velocity of particle, acceleration of particle, and other thing by this equation. So let us assume this equation as equation number 1. Now what I have to do, I have to do dy by dt here. So it's actually like velocity of particle. So when we differentiate this term with the respect of time, here we get a omega cos omega t minus ax plus phi. So this is actually our, you can say, velocity of particle. Vp means, okay, I'm gonna write in the downside. So this is actually our velocity of particle. And the next thing, if you further differentiate this y equation, so it will be like d square y by dt square. Exactly the acceleration of particle. When you further differentiate, it will be minus a omega square, because the differentiation of cos is minus sine. So sine omega t minus kx plus phi. Now, the next thing is if you do dy by dx, this is actually dy by dx is like tan theta. So if I do dy by dx, so if you differentiate the equation 1, if you differentiate the equation 1 with respect to x, so what I'm gonna get here is like minus a into k, and the differentiation of sine of is cos, so cos omega t minus kx plus phi. And if I again differentiate with respect to it, that is d square y by dx square, which will exactly give the curvature of waveform. So it is actually equal to minus ak square sine omega t minus kx plus y. Okay, so there are some again abbreviation is used. This is actually, let me write it here. So velocity of particle and APH, acceleration of particle. These are the things that we have to keep in mind. तो देखो यहाँ पे मैंने बस करा क्या मैंने देखो there are actually too many uh, ways to write the equation of traveling wave, right? So I'm assuming that our wave is actually traveling in the positive x direction, right? I'm assuming that our wave is actually traveling in the positive x direction. So I'm write the equation as according to that. Now what I'm trying to do here is I just differentiate, and when I differentiate it, what I get like dy by dt is velocity of particle. So when I differentiate, I get a omega cos omega t minus kx plus phi, whatever it is, right? Basically, a omega will give you the max velocity, right? And similarly, like AP we find, and then we try to find like what is the slope at the each instant, or the slope of the particle which actually forming with the waveform at different x and different t. So I'm just trying to find like dy by dx. And when I do so, I get the form like minus ak cos omega t minus kx plus phi and all, right? Now, there is a question which is actually what is the difference between, let me write it here. First, let me write it here the question. I hope this thing will be easy to understand because but differentiate to karni thi. So I hope you all guys are familiar with this thing. So there is actually a question. So actually it's a theoretical question. So the question is, what is difference between omega t minus kx and kx minus omega t? Right. So you have to tell like I'm just writing here like omega t minus kx. Somewhere it's written maybe it's written like kx minus omega t. So what is the actually the basic difference between these two? Right. So so the major difference is actually let's write the both of the equation and try to analyze. So here we have y is equal to a sine omega t minus kx. Right. The first thing I'm taking as omega t minus kx. So when we differentiate it, so our velocity of particle is nothing but a omega cos omega t minus kx. Okay. And here we'll get like at a time t is equal to 0, we have y is equal to 0 because as you put the time t is 0, sorry, and x is 0. So it will be like y is 0. And the velocity of particle is at the same condition will be a omega. Like the maximum velocity we have. And since it is positive, so it will be like upward direction. Now let's take the second case, which is actually we have kx minus omega t. So y is equal to a sine kx minus omega t. So when we differentiate it, like for the velocity of particle, so what we will get? We will get minus of a omega cos kx minus omega t. So at t is equal to 0 and x is equal to 0, when you put here, what you will get? You will get like velocity of particle as minus of a omega. That means in downward direction, right? Like the everything is same, like the magnitude is same, but the only difference is actually in phase, right? And the difference is by the difference in phase of, you can say pi, because both are anti-parallel, right? So the phase difference will be 180 degree. I hope this will be easily to understand to you, right? And this is actually an easy concept. So just you have to remind here ki what is actually omega t minus kx and kx minus omega t of things. Now, so this question we did. So just there is a difference of or the difference in phase. Now, we are gonna derive some of the equation by dividing the above mentioned equation. जैसे हमने यहाँ पे 4 equations हमने derive करे हैं ना, like 4 or 5 equation whatever. So like this is 1, this is actually 2, this is let me call as 3, this is let me called as 4, है ना. एंड दिस इज लेट मी कॉल्ड एज इक्वेशन नंबर 5. राइट. तो ये जो 5 इक्वेशन जो हमने लिखे हैं, जो डिराइव करे हैं, व्हाट इफ आई एक्चुअली डिवाइड dy by dt1 and the dx by dt1 and the dy by dx1. Basically, what if I divide second equation by fourth equation? This is actually the question. So let's try to find it out here. So divide equation 2 by 4. So when I do so, what will get? We'll get del y by del t divided by del y by del x. And in right hand side, like del y by del t will be like a omega cos omega t minus kx plus phi, and it will be like minus a by k. Okay. So here will be like a omega cos omega t minus kx plus phi, and here will be like minus a k cos omega t minus kx plus phi. So this and this get cancelled, a get cancelled, and here we will get, look at it. dy by dt is nothing but actually our velocity of particle, and a got cancelled, and here we will get omega by k. And we all know that like k is actually our omega by v also, and here we can write it as tan theta of the dy by dx h. So here we'll get velocity, it will be like velocity of wave. So here we can say velocity of particle is equal to minus tan theta into velocity of wave. So this is actually a relation that we get it from here, right? Again, I'm trying to say you, this is actually the displacement of the particle. This is actually the amplitude. And what I'm trying to do here is I'm just dividing the dy by dt by the dy by dx. Like that means I'm just dividing the equation 2 by equation 4 and try to find some kinds of relations here. Right. So when I do so, so what I get, like del y by del t by divided by del y by del x. So these both of the equation get cancelled, and we will reach to a conclusion. This is actually very much important because we get a relation between velocity of particle, which is actually in transverse wave in y direction, and a relation between velocity of wave, which is actually in transverse in x direction. If I'm assuming a general case, right? Because both of the velocities or the velocities of oscillations are perpendicular to each other, right? I hope this will be clear to all of you what I'm trying to say here. Here we get a relation between the velocity of particle and the velocity of wave by dividing the by actually dividing the equation 2 and equation 4, right? Which we will and the equation is derived from the general equation of the traveling wave on the string, right? And let me write here like what is actually tan theta. So the tan theta is actually the slope of tangent of yx graph or waveform. I hope this will be clear to all of you. So try to remember this form because this is actually very much important, right? Now, you have a actually question like, let me write it here. Based on that relation, right? So question 1. So direction of motion of particle of string if wave is traveling along positive x direction. Okay, so actually there is a wave. Let me draw it here. So there is a wave which is actually traveling along positive x direction. Okay, I hope let me make the complete 2 cycle. Okay, this is x, this is actually y, and you have to tell and you have to comment or the show the direction of the motion of the particle, right? So how can we do? So we have an actually relation here. Let me go to the solution. And we have an actually like velocity of particle is equal to minus of tan theta into velocity of wave. We have a relation here, right? Now we have a given one more thing here, and things given is velocity of wave in positive direction, positive x direction. That means in this direction. And so this is the velocity of wave in the positive x direction. That means this side is actually positive. So now I have to comment with the respect of tan theta. Is it upward or downward? So if I'm talking to this region, right? So in this case, if I draw the slope of tangent here, if I draw the slope of tangent here, this is actually positive. So in that region, so let me draw it here. Another graph. This is actually x, this is actually y. I can I leave it. Okay. I hope it will be clear to all of you. Now, in this region, we have actually a positive slope. So the slope is positive and this one is positive. So the overall velocity of particle is negative because the a negative sign is multiplied here. So up to this region, we have a velocity in downward direction. Now, when I draw the slope of tangent at here actually, so there the tan theta is actually negative, but the velocity of wave is again always positive. So negative into negative, it will be positive. So in this direction, we have a velocity of wave in from this region to this region, or you can say from this region to this region. We have a velocity of wave in the upward direction because in this region, the tan theta is actually negative. So overall, it makes velocity of particle as a positive. I hope it will be clear to all of you what I'm trying to say. So similarly, for this region, we again have a velocity up to this region. If again I'm able to draw the tangent, so it will be like it will give the positive slope, right? Because this is actually positive tan theta and this is actually negative tan theta. I hope this will be clear to all of you. Easy straight line things, right? So here we will get the velocity again in the downward direction. And again, in from this to this region, again, we have a velocity in positive direction. So let's start making here like this, right? So I hope this thing will be clear to all of you. And this question is again clear to all of you. So I want to make a noted point here that is actually important. Slope is positive. Velocity of particle is negative. So the velocity downward. Or let me make a table here so that will be easy to recall you because this will not work. Okay, so let me make a quick table here. I have to insert a table. I have to slope. Okay, I need, I think, five rows to be. So I think I have to insert some new table because it's become hectic to write in the right hand side. So, okay. So this is actually too hectic. Let me draw it here by my own. Okay. So look at it. Let me draw it here because it's being too hectic to like, let's take this small size. So yeah. So look at here. I'm taking for the two things here. Here is velocity of wave. Okay. Here is your slope. Here is your velocity of particle. And here is your direction. Okay. So if the velocity of wave is positive, is in the direction of positive x-axis, and the slope is also positive. So via this relation, we have actually this relation only. Okay, so we have actually this relation only. Velocity of particle is equal to minus of tan theta into velocity of wave. So this both thing is positive. So velocity of particle is negative and it is actually in downward direction. When the velocity of wave is actually positive and slope is actually negative, so this term become overall negative. So the velocity of particle become positive and it is actually in upward direction. Next, make the next table for this time. I'm gonna taking the velocity of wave in a negative direction. That means negative x-axis. velocity of wave, slope, VP, which is actually velocity of particle and direction. So the velocity of wave is actually negative. One times I'm going to take slope as a positive. So it will be in positive direction, that is in upward direction. And if I take this slope as negative, so this overall become the negative because this and this make positive, but there is another negative sign in as a prefix here. So it will be overall taken as a negative and it is actually down, right? So these are the two table which we got with the help of the above mentioned equation, which is actually velocity of particle and the relation between velocity of particle and the velocity of wave, right? I hope it will be clear to all of you. Now we derive another equation. This time actually हमने वहाँ पे above equation में, if I show you, so okay, so in actually above equation, so if you look there, I derive another things like d square y by dx square, which is actually the curvature form, the curvature of the waveform, right? So if I divide the second derivative things, right? What I'm trying to say, if I derive the second derivative things, that means the equation third to equation fifth, right? If I divide the equation third by equation five, so what we will get? Let's see, right? So let's see. Now this time divide equation third by equation five. So what we will get? Like I'm gonna divide like d square by dt square term by d square y by dx square term, right? I hope it will be easy to understand and you can do it by own. So let me do it here. So when we divide the equation 3 by equation 5, so what we will get here is actually, so let me write it here. When you divide it by here, so we'll get d square y by dt square by del square y by del square t divided by del square y by del x square. So here we'll get omega square by k square. If you notice here, if I'm just dividing the equation 3 by equation 5, so a got cancelled and we'll get omega square by k square, right? So what we can write like del square y by del t square as acceleration of particle and del square by k square as, you can write it as like curvature or something. So let me write the curvature here. So, and this is actually, what is actually k by omega by k? So omega by k is nothing but our v square, because we all know that the k is like omega by v. So it is actually velocity of wave square. So here we get the another equation which is actually v square. Preferably I'm going to write it like del square x by del and del square y by del x square. Or you can also write it as acceleration of particle is actually equal to velocity of wave square into curvature. This is actually the second relation we get of the two days. So the first relation is is actually velocity of particle is equal to minus of tan theta into velocity of wave. And the second relation we get is actually acceleration of particle is actually equal to v square into curvature. Or you can say del square y by del x square. So these are the two relation we, actually this result is actually known as linear wave equation, right? So this actually the last one, the AP is equal to 1, like AP is equal to v square into curvature 1. It is also known as the linear wave equations, right? I hope it will be clear to all of you. Now let's take a question. And one more thing, for equation to qualify as wave, it should be follow the linear wave equation. So there is actually a noted point. So let me write it here. For our equation to qualifies as wave, it should follow linear wave equation, right? So let me try to solve a question via using this, because there is a noted point which is actually saying that any wave equation who follows the result of the linear wave equation, and the linear wave equation, which is actually the d square y by del t square, is actually equal to v square into del square y by del x square. It should be. So any equation to qualify as a wave, it should follow the linear wave equation. So there is an equation which is actually y is equal to e to the power minus 2x plus 40. And you have a question, is it equation of wave or not? So whenever you have to ask like it is an equation of wave or not, so what you have to do, you have to just verify that is it qualify the linear wave equation or not, which is actually termed as, so let me write the solution exactly as del square y by del t square is actually equal to v square into del square y by del x square. So this thing you have to check, is it or not? So the first thing you have to do is like, you have to do like del y by del t. So when you do so, what do we get? 4 e to the power minus 2x plus 40. Again, differentiate. So there will be like del square y by del t square. This is actually equal to 16 e to the power minus 2x plus 40. Now, the things you have to do like del y by del x. So when I do del y by del x, it is actually is equal to minus 2 e to the power minus 2x plus 14. When I do del square y by del x square, it will be actually equal to 4 e to the power minus 2x plus 14. Right. So just I'm trying to do like double differentiate and all kind, right? Now, let's check. So del square y by del t square is actually is equal to 16 e to the power minus 2x plus 40. And I can write it as like 4 times of del square y by del x square. So we have a relation here, which is actually del square y by del t square is equal to 4 into del square y by del x. And if you look at here, like it is of the form like t minus x by v. So here is like a velocity of wave. If I'm gonna talking about is actually, this is actually the 1 by v square. The 1 by v, or you can say 1 by v square is equal to 1 by 4. So here the v square is v is equal to 1 by 2 meter per second. Right. I hope this thing will be clear to all of you. Right. So we just have to satisfy this. Now there is another method which actually help you to verify that the given equation is the equation of wave or not. Okay, so how can you do so? So the things you can do here is, let me write it here. Method 2, I'm gonna write is you can also call it as heat and trial method. So first, in phase x, v, and t should be linear combination whose highest power is 1. Next, the B part, which is actually considering as y should be finite for every value of x and t as y is bounded. And the third thing is like the function should be periodic. Function should be periodic. Right. So these are the things that I'm going to talking about here is, let me tell you again, the to qualify equation as a wave equation, we have to follow certain things. The first thing is like, if the given equation is satisfy the linear wave equation, which is actually in which velocity of wave square into uh, curvature is equal to acceleration of particle, right? So if it satisfies, this is actually the first method. And the second method is if the given equation has a XVT, which is actually phase should be linear combination of XVT. And Y should be finite, that the displacement of particles should be finite for every value of X, T, and the third thing is like function should be periodic. This thing you have to keep in mind. The function should be periodic. If the function is not periodic, the given equation is not the equation of wave. If the Y is not finite, the given equation, if the Y is not finite for each time and each X, for the every value of X or the every value of time, so Y, so the equation is not the equation of wave. Okay, so these are the things that you have to keep in mind. I hope that's all for today. In tomorrow's class, we are going to discuss about the velocity of wave on string. Velocity of wave on string. So, okay, that's all for today. Thank you.